you, Wendy, for closing this thing. I appreciate that the select few are here. So I imagine we will have a really nice conversation with the opportunity for questions and answers. The topic of today's panel is open science, epistemic, ethical, and practical issues. This has been put together by my friend and colleague Connie McNeely from George Mason University. And the four speakers, I'm the moderator, I'm Ester Sztein from the National Academy of Sciences. And the presentations are going to be given by Erik Kuiler, Heng Erik Kuiler from George Mason, Heng from Penn State, Wendy Mann from George Mason, and the final one from Feras Batarseh from also George Mason University. And the idea is to have about 8 to 9 minute talks. We'll go through the talks as they come, and then we'll have the remainder of the time for questions and answers. And take notes, don't be shy, and then we'll talk about things. This is a fascinating topic. So let us get started with Erik, who will talk about open science, concepts, frameworks, and perspectives.
Thank you. As beyond the conceptual, open science has been going on quite a number of years, starting in the 8th century before the Common Era, when the Greeks started exploring their way into Asia Minor, and they run into the Hittites. So they learned how to manage a chariot. So this is an old concept. Aside from that, I will try to update it to at least the 17th century. Okay, the overarching principles are, of course, fair, findable, accessible, interoperable, reusable data, and information research. The other thing that should be of interest to us, especially now in the, with very large data sets, is research ethics. How do we conduct our research? Its formulation, its dissemination, so that it will comply not only with our own ethics, but also national ethics and inter-community ethics, ethical standards, and that becomes especially important when we start dealing with the Internet of Things. And what happens there, we have a multiple set of devices talking to each other. The reason why open science is important is, one, we have all of us who work in academia or for the national government, they're epistemic silos. We don't talk to each other. You can have multiple people who, let's say, deal with health policy in the health policy program, the public policy program, in the data science program. And that's not just at the university we are from, it's also, I talked to a friend who's at the University of Delaware, she's running the same problem. So that's one of the problems we're trying to deal with is. We're also trying to enable, as opposed to just reinforce, interdisciplinary cooperation. Much as when we deal with ICT, as we talked about in the prior session, some of you were here for that, it also depends, the use of ICT also depends on culture and institutional concerns. Issues of security are, of course, important. Heng Shu, I assume, will address that. That's our expertise. I'm not going to presume on your epistemic discipline. And then something that I'm interested in, and some of my colleagues are interested in, which is data interoperability and to support data sharing. With that in mind, what the perspectives I'm planning to take is look at the infrastructures, then look at data source, and look at ethics. This is my attempt at providing a conceptual framework for the three infrastructure I'm talking about. I'm talking about within the context of security, for not only data at rest, but also data at motion. And I'm talking about access to authorization, transportation, so on and so forth. Also something that I am very interested in, which is the mundane aspects of open science, governance and management. This is always overlooked. We always look at the gee whiz of things, but not on how we manage this stuff. Same with analytics. We always go, wow, you know, this is the great stuff. So I also want to focus on data infrastructure. There I focus primarily on interoperability, the use of lexica ontologies. In cyber infrastructure, this was a term that gained popularity because Mr. Al Gore used it. and also on data sources. And big data or very large data sets, or big data in the dark speech or Mordor, little data, and IoT data. Okay. I assume someone else will talk about it, but here are some of the topics that always come to my mind. Data at rest, data in motion. Data at rest, because we have done this for a long time with databases, also distributed databases. Data in motion, you started dealing with encryption and decryption. That slows down your processing time. I know of no efficient way to do that yet, but then again, I'm not an algorithm developer. Access, authorization and control, the multi-tiered levels of access, control, and authorizations, the things I can immediately worry about, now that I'm into governance. And ontologies is computational network and the data grid. How do I keep those secure? Especially when you have so many devices that communicate with each other and you can overwrite. The classic problem if you're a tester, if you've ever done software development, what's to worry about with testing? Your fault overrides my fault, so it seems as if the data are correct and they are not. So we're dealing in many ways with unintended data corruption. Data transportation, we have to worry about transmission protocols, also source and target service levels agreements. What do we do if you send me corrupt data? It's rarely addressed, but you need to address it if you're dealing with not only intra-universities, but also intra-agency definitions. Also, what are your metrics? How do I measure the efficiency of my interprocessing? And the other thing that should be done here, and this is only recently gaining attention, data analytics lifecycle. From the ingestion, or as we say, if you go from a data warehousing environment to a, let's say, data lake environment, extraction, load, transform, as opposed to the extraction, transform, load, that type of thing. Your paradigm is now reversed. That has got to be addressed. Okay, here is where I think we are lacking. We don't talk much in open science about data stewardship. Strategic data management, oversight, and coordination. Especially think about it, I have multiple positions where I need to deal with lexicon and ontology support, data quality. I could talk about all of this offline. I don't want to take anyone's time away, so let me skip through this. Collaboratories, this, that. The other thing. Oh, here we go. Since I only have 2 minutes left. What are the problems we're really trying to solve? Within the epistemic infrastructure, is it the duration of the current peer review process? Is it the publish or perish culture that we should be addressing? Which I think we should. I think it's ill-advised. And especially when we measure popularity of our research by the number of citations or blog entries. If you look at altmetrics, you look at weighted counts of news items, blog entries, and Twitter entries. What's the problem with that? We go only into research that is popular because it'll get us tenure. Is that the proper way to do research? This is one of the questions I would like to see us addressed in this symposium, because there may be different ways we can look at it. Are things that are good, like peer review, we could change the peer review. Anonymous peer review, we could also have open peer reviews, but then the question is what happens if somebody who's not qualified cannot read it, cannot understand your. All of us who had articles rejected this, we can end up saying, did you really read what I just said? I mean, do you want to do that on a large scale? And, or you could do annotation services and all of that. Also, the issue of publications, I like to see more e-journals. E-journals are a useful way to disseminate knowledge, as well as traditional things. The thing that I do like about open science is the shareable repositories. For example, I work in health informatics. I'm interested in the NIH has a very good metathesaurus. I suggest if you're looking for a model of what a metathesaurus should look like, you should look at NIH. You should also look at open archives. How much time do I have? I'm good.
You are done.
I'm done? Literally or metaphorically?
Yeah. No.
Okay. Data sources. Okay. Here, different contexts. Here's what we need to focus on. Semantic frameworks differ between epistemes and what's already within epistemes. If you look at genomics, We have epistemic cognates. My notion of capital is different than your notion of capital, yet we use the same term. Syntactic conventions, the way we address things, the way we do things. Symbol systems. You know, if anybody who's done coding in assembly language knows what I'm talking about. Your null space is different than my symbol for a null space. The old hex 40 problem. For example, in genomics, different standards. We have European standards, we have American standards. We need to worry about those things. Open science ethics, autonomy, voluntary participation, non-malevolence, benefits, justice, and fidelity. We are familiar with this. Most of us do our research this way. But this, for those of us who are in IT, I've decided to put this up here. This is the Mauritius Declaration. It was published in October of 2014. And notice what it looks at. We tend to focus just on academic open science. But when we start dealing with Internet of Things, with devices, we have got to get the manufacturers involved. We have got to get testers involved. We have to get the software engineers involved. Because as I mentioned before with testing, you know, I can do testing and I write it as a black box and my interface is good. I've tested to anybody who's done agile programming or object-oriented programming knows what I'm talking about. Yet I hand it to you. I don't know what you do with the data. It's issues of risks and responsibilities, authorships, and so forth that we have to worry about. Okay, issues, yeah, I just mentioned them. And this is a final quote that I like, and that we must always forget: the opinion which is fated to be ultimately agreed to by all who investigate is what we mean by truth, and the object represented is real. In other words, science is a social construction. And Charles Sanders Peirce was a very good scientist, and he is the mainstay of pragmatist philosophy is practiced in the United States. He has a very great influence with Whitehead on education. Thank you.
All right. Well, the next speaker is Heng from Penn State.
Should I switch slides?
I'll stay here.
Sure.
Okay. Good afternoon, everyone. Thank you for inviting me here. And I really like Erik's talk, which actually gave me a natural introduction and link to my talk. And I will briefly talk about the challenges in terms of privacy and security in the context of open science. So first, I will talk about data privacy. So think about if we try to be open, right? Imagine the future where we publish our articles, and then we try to make our data available so the reproducibility of the results could be widely available to the whole research community. And what are the potential challenges in terms of data privacy? So when I talk about data privacy, I talk about those data sharing practices in the context of medical research or social science research, where these data sets can be easily mined to identify human beings. And I would like to let us to think about privacy challenges from these three different perspectives. First, human subject privacy. What do we mean by privacy? To every one of us, right? We may mean different kinds of things. And especially when we operationalize the notion of privacy, we may mean different things. One of the popular operationalization of privacy in the context of legal compliance or the industry would be personal identifiable information. And when you think about privacy, if we equal privacy to personal identifiable information, the notion of personal identifiable information is also confusing. What do we mean? What types of information are considered as personal identifiable data? I'm giving you one example. how about IP addresses? In European Union, IP addresses are considered as personal identifiable information because you can actually accurately try to mine this person's geo-information, right, geolocation out of IP addresses, and then integrate that type of data with other third-party databases, like you can easily infer the zip code, and then you can easily infer the house prices, the type of neighborhood they live, and then you can mine the identity eventually. But in the United States, IP addresses, especially to Google and Facebook, these big industries, players, it's not considered as personal identifiable information. So that's a huge challenge, even we don't have a consistent understanding about the notion of privacy. And then the second challenge I would have us to think about is from what I call adversary knowledge. What do I mean here is about the technical challenges in terms of how to anonymize data. And then those anonymized data can be re-identified. It's not new. This stream of research actually happens. Okay, it's not working.
We begin to point backwards.
Oh, backwards.
No.
No?
No.
Next slide.
I did break it.
Oh, this
Sorry, I'm gonna have to,
Can you just help me play this slide?
yeah.
Sure. Great. So.
I always love when you talks on technology.
Yes. It's perfect timing.
Sharing
Yes.
knowledge.
It's perfect timing. So the technical challenges are not new. Back to the year of the 2000, Professor Sweeney showed that 87% of all Americans could be unique identified just using 3 types of personal information, which are date of birth, gender, and zip code. So with using these 3 types of information and aggregating these 3 types of information, any so-called anonymized information can be easily re-identified. And next slide. And here is an interesting experiment done by a group of behavioral economics researchers in the year of the 2009, where they tried to apply that de-identification technique to publicly available data sets. So what they did is try to utilize the Social Security Administration's, what?
Oh, it's working.
Oh, it's working?
Yeah.
You made a magic.
I don't know.
Thank you. So they're utilizing this public data set from Social Security Administration's desk master file and try to identify those files with other public available data, such as data from Facebook. And they showed statistically possibility in terms of predicting these human beings' social security numbers out of these 2 different sources of data. So this is a successful case where try to applying the data re-identification technique to different sources of data and then mine the social security number. So it's pretty scary. And all these cases, these techniques has been developed in the past 30 years-ish. There is no such advancement. But here I want to demonstrate another case in the context of open science, where this particular group of researchers, they published this article in this medical journal, and they are doing the exactly same thing. They try to re-identify or demonstrate the statistical mathematical possibility about identifying human beings from only using 4 types of data attributes in anonymized medical data sets. And a kind of, story out of this, I know one of their co-authors. So one story behind this article was they were approached by the editor-in-chief of that particular journal, where the editorial board members are debating among themselves whether they should push for open data policy for those articles published within that journal. Some strongly, push that movement, but others showed their reservations. So they actually tasked this group of researchers and to demonstrate the extent to which, if they are pushing this open data policy, whether there will be privacy expectation be, broken. So what they did is, in their data sets, they only have a code dedicating the hospital names, gender, quarter of the year where the patient received the procedure, and the exact procedure codes. The procedure codes actually look like this. This is a medical, procedure codes, and this containing meanings of the exact procedure they did. Okay, so if you look at the first line, if this data set only contains one primary medical procedure code, and they demonstrate in that data set 16% of those records can be uniquely derived. That pointing to the portion of the patients. And when you add the number to 8 different types of medical procedures, the percentage of unique identifier, unique identified health records actually increased to 98.6%. So what does this mean? The more numbers of medical procedures they can get, the higher possibility about deriving or the possibility of uniquely identifying each individual or human being in that data set. So these are kind of demonstrated the challenges from the technical perspective. And next I want to talk about the third perspective is about data utility perspective. We are actually pushing, the open science. We have a lot of algorithms being developed. The most significant one and the recent movement in the technical community is about differential privacy. And the algorithm is designed in a way balancing the utility of data, versus privacy treatment. So basically it's that trying to balance the trade-off. When you try to protect the identities and then differential privacy try to add noise to perturb the data, but meanwhile, they try to achieve a balance in terms of still trying to make the data usable by the researchers. So this is the latest scientific movement. And then I will conclude my conclusion by highlighting some of these preliminary thoughts about open science from security perspective. And think about if we open methods and open data, attached to the research, or especially in the context of security research. Essentially that makes hackers, right, make their job easier to figure out how the system works, and then they can easily figure out the way to hack through the system. But in the open source community, in the past 10 years of research, there was one stream of research demonstrate that open sourced codes can actually have a faster speed to catching those vulnerabilities. Because once you open, and then you have more volunteers or more possibility about catching those vulnerabilities. So it has been debating, shall we open or less open, even in the context of cybersecurity research. But the recent thoughts from security research community is that we should think about security by design. Assuming the system design to be public knowledge, and our job for the system developers or cybersecurity researchers is to make the design inherently secure, even when a hacker knows how it works. So with that, I would just conclude my perspective about security and privacy challenges in embedded ways, open science.
Thanks.
Very good. So the next speaker is Wendy Mann from George Mason University.
Sure.
And let's hope that technology gods smile upon us.
Waiting for my slides.
Okay.
Alrighty. Okay, so I'm Wendy. I am going to talk today about what university libraries are doing to help support open science among researchers at academic institutions. But before I go any further, I could just show you this slide and say I'm done, because this report was just released 2 days ago by the Association of American Universities and the Association of Public Land Grant Universities. I recommend you take a look at it. It's only a 9-page report where they make recommendations on what academic institutions should be doing to support open science. And I will be talking about a lot of these concepts today. So I can't talk about open science without talking about the research life cycle, and I'm focusing on research data. And so I'm sure you've seen a bunch of diagrams out there about the data life cycle. And so those of us in libraries and also researchers and information scientists are kind of concerned with this cycle and where research falls in the cycle and how we help people, how we make it reproducible, reusable again and again and again. So again, to meet fair data principles, to help meet funder mandates from NSF, National Institutes of Health, for example. Data management and sharing is something that I'll be focusing on and talking about kind of the research life cycle today. And one reason I decided to talk about what libraries are doing, because while I see faculty and grad students who need assistance, I also hear from a lot of people who aren't aware that libraries are doing this. And this is something that comes up at conferences that I go to, and so it's just something, there's always this kind of issue raising, awareness raising thing that needs to go on. But what I would like to kind of go into a little more detail about today is data management education and training, hosting institutional repositories, participating in national and international initiatives which promote data sharing, and providing access to tools to facilitate good data management, open science, and reproducible research, and interpreting data management and ownership policies, copyright, and author rights. So following best practices for good research data management is essential to ensure the data is findable, accessible, interoperable, and reusable. And as many agree, this is underscored by the fact that principal investigators are expected to submit data management plans with their research proposals to funding agencies like NSF and NASA. Academic libraries, either on their own or in collaboration with other campus units, and even with outside organizations, offer research data management training to researchers so that they can learn best practices for managing their data. Typically, the data management education includes, and this might seem like common sense to some of you, but there are plenty of people who also need training in this area, is how to document and describe data through README files, code books, data dictionaries, lab notebooks, and so on. What I often tell people is if they are using somebody else's data set, think about what it is that you would need from them in order to use that data set, right? You need the documentation, the information, the methodology, all of that stuff. What metadata standards exist, what's appropriate for the information type, offering expertise to describe research output using appropriate metadata. And so again, this is another area where there are many researchers who aren't even aware of the numerous metadata standards that are available. Organizing and naming files through standards and protocols for file naming and setting up directory and folder structures. Again, it seems really mundane, but organization really begins at like a very low level. And then also various methods of version control, storing and backing up work, what resources are available to one's home institution, as well as policies and procedures for working with sensitive data, and following federal guidelines such as HIPAA and FERPA. And finally, hashing out or understanding data use agreements, author rights, copyright, and providing open access publishing funds is an area where libraries support the final dissemination of research results. Some libraries have open access publishing funds to help cover the costs of publishing in non-predatory open access journals or open access repositories. And scholarly communication librarians can help interpret journal publishing agreements so that authors can negotiate and not give up their copyright rights. So in terms of training, again, I mentioned how different institutions and this data management training is predominantly occurring at university libraries, but also in collaboration with the Office of Research and with IT. And so it's really important at the university level that all of these units are working together. And in addition to that, there are plenty of libraries and data archives and organizations around the world and across the country that offer data management training that we rely on, we utilize, and that we refer many of our users to. So here's some examples. Data One is an organization that has put together really, I think, well-designed data management modules. They deal with kind of earth science and ecology. The Mozilla Science Lab, Project Tier is great for teaching faculty how to train undergraduate researchers. And so these are just some examples of resources that are available out there. And again, a lot of the people we see are usually grad students, undergraduate students as scholars, new faculty, and also some seasoned faculty too. So I'm talking about data management training and also data sharing in open science. It's important to kind of clarify terminology too. And so as we're working with people from different disciplines and different departments and units on campus, it's important to be clear about what we're referring to when we talk about archiving and a repository in open science, and then also in the library and information science community. Usually when we talk about archiving data in a repository, we mean a specific type of repository. So it's a system that's designed for collecting, archiving, and preserving data. It's something that usually meets these standards as Open Archives Initiative Protocol for metadata harvesting. And so that's the metadata in these systems such as, say, DSpace or Fedora, which are two examples. The content gets crawled and appears in search systems like Google Scholar. So then that makes the information more findable, say, as opposed to just linking to files on your own personal website. And then in archive, we mean archiving data for future use. So not something that's going to sit in a data center on a server that's not going to be touched, but something that's actually in a format that is saved for reuse and put in a location where it can be used. So again, as we're working with IT and researchers, it's always important to kind of clarify these terms. And so I thought I should do this for now. And then I had to show you this fun diagram, which is the whole open archival information system model. So again, when we're talking about open science and archiving data and archiving research so that it can be reused, we're really referring to things that meet these criteria. And this is an international standard also, this particular model. But it's the whole process, the people, the process, the software, everything, the hardware, all of that that is involved in preserving, managing, and making information available and findable. Just a screen snapshot of a few projects. So I mentioned AAU and APLU report earlier. Project Share, it's called Share Notify, which is a project that was designed by the Association of Research Libraries, AAU, APLU, and the Center for Open Science. And it searches across any institutional or domain or subject repositories that are registered with Share Notify. So this is just a screen snapshot. There are, I think at this point, well over 100 repositories. So you could search across Share Notify to pull research out of these individual repositories. Also re3data.org, which is a registry of research data repositories. So as opposed to searching across content, RE3Data is an international project from DataCite, and they pulled in another project that was being carried out at Purdue University that searches across, it's an index to repositories, so finding out whether or not a repository exists. And more repositories are popping up, so this is also important. We also put people in touch with or alert them to the right kind of tools that will help them with their research. So again, the Open Science Framework, which is designed by the Center for Open Science, which fosters, again, good data management, research reproducibility, and making sure that you're well organized throughout the whole research process. So again, you see the little circle for the research life cycle in their logo. And then other things like the DMP tool, which helps, that was designed by the California Digital Library, which helps people write good data management plans, hopefully. ORCID IDs, which are used to create unique author identifiers for tracking research. And then EasyID, which is something that we use to assign what are called digital object identifiers to unique digital objects. And then very quickly, I know we were talking about, like earlier, I think Erik had mentioned the issue with data policies. And so it's really important, and this comes out in the AAU and APLU report, that universities at the university level are very clear about what they expect from researchers in terms of data management. And so a lot of data management policies, or just data policies in general, are vague, and researchers aren't sure what to do. And so this study was done, it was published in 2015, the data was collected in 2014, but these researchers looked at research universities that fall in the very high and high research activity Carnegie classification, and out of 206, they found that only 90 had some type of university policy covering research data and telling researchers what they're expected to do. And then what a policy looks like. Here's a nice one I like from University of Virginia on laboratory notebook and record keeping. There's a nice policy. It tells researchers exactly how they should keep a laboratory notebook. University of Pittsburgh guidelines on research data management. This goes on for several pages, describing to researchers at the university how they should be managing their research. So it's policies like this at the university level that can help us kind of foster open science. And that's all I have for now. So I'll answer questions later. Thank you.
Very good, and the last talk is by Feras Batarseh.
All right, I hope I'll provide a good wrap-up to all the great discussions and the presentations. Okay, cool. All right, so hi everyone, my name is Feras Batarseh. I'm a research assistant professor at George Mason University, College of Science. The title of my talk is "An Open Mind and Open Science," and I'll explain that. I'll explain why I chose that title. But given that I only have 9 minutes, I'll begin with the year 1610. And in the year 1610, Galileo was looking through his telescope and observed some rings around what he called a distant planet. Now, these obviously were then famous for the rings around the planet Saturn. When Galileo realized the importance of his or the significance of his discovery, he wanted to share it with someone so no one else can steal it. So he wrote this string and sent it to one of his colleagues, which is basically an encoding of what he actually wanted to say, which is that in Italian, or Latin actually, sorry. Latin, and then he's saying, I have observed the most distant planet to have a triple form, right? That's Google Translate, so that's the best translation I could do. But So the idea was that he wanted to conserve his observation, and I guess most of us in research, we live in our own silos. We rarely go outside and see the sun and meet fellow Homo sapiens, and we're usually working alone, like I guess my colleagues mentioned, and we want to get a research result, run an experiment, and publish it. Now, so actually that was called the commitment scheme back in the day, what Galileo did, and that was actually very common. That was one of the only forms of sharing science or making sure that no one else is stealing your research. So nowadays, luckily, awesome, we have publications, we publish in journals and reports and white papers and surveys and conferences, and we can go and claim victory on problems that we solved, right? We put our name on a conference or in a journal paper and publish it, and that way everyone knows that we did that. Now, now the problem, as also my colleagues already mentioned, is that once publication is out, there's very few studies get reproduced, replicated, right? Like I think some of you mentioned. And also the data that's used for that publication or for that research is also not available for anyone to reproduce it. So not only that the data is not available or the research is not reproduced, but based on there's been lots of recent, lot of voices talking about the correctness of research, even what's getting published out there. As Erik mentioned, if you're an academic, if you want to get on tenure, publish or perish, more papers is better than less papers. Even if you have less papers with higher impact factor, you would want to get as many papers out as possible to get tenure. And that is obviously not good for science. There has been many studies out there looking at the correctness of the research, and the results were pretty fascinating. 65% of studies could not be replicated, meaning the data provided and the environment provided and the preconditions of an experiment are not enough to replicate a study. 70% of medical studies, how dangerous is that? 70% of medical studies have false positives in their outcomes. Usually you have small experiments. A small experiment can lead to a higher probability in false positives and so on. So there's a lot of talk about p-values, and that's, if anyone of you are familiar with p-value, p-value is the probability of your null hypothesis to occur in an experiment, right? And also very few studies use certain statistical measures to evaluate the results of the research. We often look at the research, we have a control experiment, publish the results, but very rarely we evaluate these results using significance or p-values or other types of statistical measures. So, what's besides all the reasons that my colleagues mentioned, what else is wrong? I'm sure we all read articles in newspapers and magazines through cool visuals and images about how wine is equal to 1 hour at the gym, 1 glass of wine, or one famous one was the green jelly beans cause acne. It's a loud example of how correlations can be drawn through a wrong study, right? And there are many other ones. Artichokes save you from cancer, and tomatoes, improve your life, your health, and all kinds of inaccurate studies out there that eventually find their way into our conventional wisdom, and you find we tend to use them in our conversations and personal or professional, and they in many cases also affect policy making and decision making in our organizations and so on. So I created a list of reasons of why do we have such a crisis, besides all the other examples that my colleagues mentioned, and this is by no means extensive. I'm sure there are many other reasons that you all can think about. But besides all the scientific reasons of reporting false positives, small experiments, the design biases and the data sets and random sampling, there are many institutional reasons. So the publication, how many publications an academic needs to have to keep progressing. Publications are the main career currency in academia, so it's very important. There's no value whatsoever in producing research. If there's a study that's being performed by a university and it's already published, another university or another research lab rarely gets the same data set and reproduce the data, right? Yeah. And then the peer review process, I think Erik mentioned that briefly. The peer review process is very poor. We all got reviews from colleagues with like on a 40-page paper, like one sentence or a couple of bullet points. Not comprehensive whatsoever. The problem that it's free, I review papers all the time. I try to do, as good job as I can. The problem is it's unpaid for, it's free, it's random. The process is not standardized, it's not unified. And also, I think one of the biggest issues is there's no access to the research building blocks. Now, some might say, well, isn't science all about trying different things and getting papers out, and then you can pick and choose what you want to believe or reproduce. But the problem with that is not only that it's most of the time inaccurate, but also it's very expensive to get these papers. So at the Fenwick Library, George Mason, we can get all the papers and books we want. We have that kind of access. But many folks outside of academics or if they don't have access to any kind of repository, they have no access to such publications. And they are very expensive. I don't know if you're familiar with this movie. Anyone saw this movie?
No.
So The Internet's Own Boy is a story of Aaron Swartz. Aaron Swartz, in the early 2000s, began a movement, and he called it the Open Access Manifesto. His goal was to collect as many publications as possible and put them in an online repository for everyone to access. And this is the part of the text of the manifesto. Now, the end of spoiler alert for the movie, but the end of Swartz, Aaron committed suicide in 2013 after being prosecuted with multiple cases of fraud and hacking and breaking laws and stuff like that. And the main I don't want to say enemy, but the main entity that him and the open access movement in the early 2000s were trying to compete against were all the publishers that we all publish with, right? Okay, yeah, we're all publishers that we publish with. So if you look at any of these publishers and many more, right? It's very expensive to get a paper. I mean, if you want to buy a paper, usually one research paper is like for $40. And when you're doing a study, you probably need to read like, 50 papers and reference 30 in your paper. So imagine how much money that would cost a student to perform a study, right? So based on everything that McNeely's mentioned and what I briefly also mentioned in my talk, how do we get to open science, right? So it's not, we talked about open data libraries and how, it's multiple things, right? So annotations, open access, open data, internet policy, open code. Someone mentioned open source code and how it has less possibility of being hacked. Open source has been very successful in data mining and artificial intelligence. Opening the internet, we recently been following the news with net neutrality and how that being debated, and it's endangered. And if net neutrality gets taken away, that's probably one of the biggest risks to our freedoms and personal liberties and science in general. About open data is obviously very important. There's an open data initiative. We published a book, Connie and Erik have a chapter in it, about federal data science and how open data can help with data science and how the government needs to adopt more data science for its processes and so on. And in the spirit of open science, if you're interested, I can send you a free e-copy if you want. Yeah. So I'll use my email at the end of the talk. So the bottom line, in my opinion, open science is multiple different parts. Many things need to be accomplished before accomplishing data science. These are the 6 pillars I could think of, but I'm sure there are many other pillars that you all can think about. The reason for the title of my talk is, these are 6 accomplishable pillars, but most of them, to be accomplished, require an open mind, not only by scientists, but also publishers and policymaking officials and politicians and so on. We saw some good examples, some silver linings. Anyone familiar with the polymath experiment? The polymath experiment is a great example of successful open science where Dr. Gowers in 2009 published a mathematical problem on his blog. And the first 20 days, there were no replies or responses. But then after 20 days, many researchers and professors posted answers to his problem. And they on the Polymath project website, if you go to it, you'll see discussions and solutions to really big mathematical problems that haven't been solved for ages. And obviously, being academics, they eventually published papers per problem. So this is a very good example of open science and how it can be very successful. There are many other ones, and I try to stay away from the ones that are managed by publishers per se, because these are, yes, they're open, but they're expensive, right? They're open to certain people. So there's like green open access and gold open access, different types of openness, which makes a big difference. GitHub, for example, a website also partly started by Aaron Swartz, is an open access, open code website. We talked about the Open Science Framework, OpenAI. The UNESCO has a program for open science, for publishing, Kindle, direct publishing, Hadoop. Some cities open their data to the public for research, like Chicago and San Diego and Seattle. Only few cities in the US have their data. Okay, yeah. So, and that's it. Thanks so much.
Okay, so stay there. I think we have a few minutes for questions. And if the speakers would like to come and speak at the front.
Oh, you want to? Okay.
Or close to the front.
Sure.
So anybody has questions to kick this up?
I do.
Okay, perfect.
A technical one. I've dealt with structured data, and I've done security at the tuple level, at the instance level. Would you recommend doing that? And if so, how do we expand that notion of record-based, instance-based security to, let's say, unstructured data?
Security, you mean?
Access, in other words, I can limit your access to this particular instance.
So case by case,
Almost case by case.
You're
yeah.
talking about like case by case.
Case by case, because we both have dealt with PII. And one of the biggest issues is how do you write an algorithm that can ensure uniqueness, given that there are X number, the more data you have, and this is also a data mining problem, the more data you have.
So which means that if you want to see whether you employ access control mechanisms to the personal identifiable information, you don't want to apply any privacy protection, algorithm to add noise to the data. You want to keep the authentic data sets, but then at the access level, you add security layer?
Something like that, yeah.
Well, that's what, a lot of agencies has been doing, like, census data sets,
Sure.
although they give you aggregate levels or characteristics, and they have, these kind of special process data, they still have access control mechanisms, right?
Yep.
They're not the role-based access control or other fancy control mechanism. They are more utilizing the physical limited access, right? Whether, you can only go to these data centers to do these kind of analysis without, downloading the data.
Because I've done role-based access limitations, and that's straightforward, but you can always bypass those, and that's what I'm worried about.
In the context of health research,
Yes.
in the large, hospitals or health-related institutions, different types of, role-based access control mechanisms are more popular because if you add noise to the medical data sets, the utility will be significantly lost, right?
And the other thing is too with the IoT, where all of a sudden devices can add data to your, let's say, your electronic health record and embed it. And I'm always very worried about, hacking IoT data or just corrupting IoT data before it gets to you, before it gets into the record. And somebody's got to go and make it prescriptive, and then you add prescriptive analytics on top of that. And you're killing people, and you don't know you're killing people because you're acting in good faith. This is one of the problems I worry about, and especially as an old data scientist and an old data architect, it was one of my major concerns.
It really depends on the different types of data and the nature of the data. Some, like access control type of mechanism from security perspective might work, but other types of data sets where you cannot add those layers, and then you have to looking into other mechanisms to make
especially if we go from data warehousing to data lakes, it makes it even worse, where you have so much data, and this is where the near instantaneous availability now becomes a problem. And now I've got to put my filters on the back end, and that makes it much more difficult. Especially if I do it on the cloud, if it takes me a week real CPU time. And I use the cloud, and now I add the other layer of cloud security on top of that. I have a real problem, and people may die because of a security problem, and not a diagnostic problem because everybody acted in good faith. That's what I'm getting at.
From practical perspective, all these sounds like an econ model where you have expenses of doing this, and then in some field, like say in the health sector, you have this legal compliance, right, to take care of, and then you also have utility data users. They extend to wage whether the utility would be lost because of security or privacy treatments of those data. So all this, comes to one formula where it's kind of dynamic based on, the user of the data, the purposes of data, and then the function of all these factors coming into one formula.
And I don't know, and maybe that's my limitation. I'm more practical than theoretical in computer science, is I can't write an algorithm that shifts to accommodate these multiple contexts that we've been talking about. And that's maybe my limitation.
Well, you talk about unstructured data, and in that aspect, you're protecting that channel and not the data itself.
That's my problem.
Right.
And the channel, that's fine. It's sort of like if I have a navigable river, I put buoys in the channels and say, go here and don't go there, you dumbass. Oh, you dumb person. But that's like in a network. And I'm going, wait a minute, I've been there. I still have problems. Also, when you talk about p-values, I'm 95% sure that this is correct. My sample replicates my population. Put it in real life. If I have 9% of my people who are not covered in a city or in a country like a small country, let's take the Netherlands. There's 13 million, out of 13 million people, 1.3 million people are in that uncertainty gap. How do I deal with that? That's the issue with data mining that comes up. In addition to the security. Now, I'm stymied. I don't know what to deal with it. I'm taking everybody's time. I'm sorry.
Yes, Connie.
I actually have something to ask everyone, but I would start with Heng. Just in very basic terms, the issue comes up now. Does privacy actually have any meaning anymore? Is privacy even a right? I mean, since you address this as an ethical kind of issue, does it even have meaning? Have you seen this little video, which was made a few years ago, the ACLU video on the pizza delivery? I mean, do you all know what I'm talking about?
No, I haven't seen it.
Can you describe it? It's
That video actually kind of envisioning our future about, a pizza shop, a little pizza shop actually have access to all your data sets where, first you started out, they're essentially a recommender system based on the access of your weights, health records, the type of neighborhood you are living. And
your vacation plans.
the vacation plans.
For your vacation.
Yes,
Yeah.
the plane.
Yeah, they recommend you, a healthier portion of pizza order, and they say, why I need to do that? They say, well, because you just purchased a pair of jeans and the size of 12, I think we suggest you to pay attention to your diet. Yeah, so all these little shocking suggestions, right, based on, yeah.
That was the thing. You know, so all things considered, it's if you brought up the issue of privacy and what that means doesn't mean anything if we continue along these terms, along these lines. I mean, and anyone can speak to that. I'm just saying.
So privacy to different people means different things, right?
And is it right?
Yeah. So here is a little kind of, the nuances. I always try to achieve a balance, right? The other day I was talking with a marketing researcher, and they say, well, privacy versus, data utilization and personalized ads has been a debate in marketing in the past 30 years-ish, right? And then you're using same piece of information, but then the outcome of your recommendation might be totally different, right? You know me, you know my size, and then you are recommending me to a beautiful dress, right? If you say, here is a beautiful dress, you may consider size 8 versus now I know you are size 8, you have been increased 20% of your weights. I'm recommending you, health club, membership, right? So the latter, to some people may feel offending. But then to others may think,
oh, it's helpful.
It's helpful. I never pay attention to my weights increase. And thank God you nudge me to, I need more exercise. But then to some other people think, what's wrong with you? Why you are invading my kind of space and nudging me that I'm too fat? So all those kind of, responses.
And you shouldn't order that pizza.
So it's very different kind of perceptions.
I have a comment though, because on this interchange, the notion that still makes it work, there's volition. You can choose not to. What happens is if you go into prescriptive analytics, let me finish. I go into prescriptive I go into prescriptive analytics. And now I have all this stuff coming in, and it recommends a particular, let's say, dosage of a drug. And for God's sake, that dosage is going to kill you, and you don't know that. That's what I'm worried about, because now you take volition out of your voluntary, I'm going to follow this, out of it. That's why I'm profoundly worried when we talk about, that's why I call it the dark speech of Mordor, when we talk about big data and analytics. And we go then, everybody, and I work in the healthcare community, everybody's going gaga, and the AMIA, American Medical Association of Informatics, about prescriptive analytics. I'm going to these guys and saying, wait a minute. You're going to kill somebody, and who's responsible? Is it the device maker? No, I coded this stuff in good faith. I'm an ex-code cutter. I did it in good faith. I tested the dickens out of it because I knew it was going to be in the healthcare industry. Is it going to be? And my lawyer isn't going to help me because I'm dead. This is really something that really bothers me, because I take volition out of it. And all the other things, and we could talk also about identity. We did it in last DuPont, where we talked about the Chinese notion of identity is different than our notion of identity because of communitarian basis. That also has to be taken into account.
But you can deal with that. I mean, you could come
that
up,
I can deal with,
you could come up with a standard, an international
definition
standard or something
Yeah.
that's defined in particular ways, irrespective of the cultural variations.
That you can.
You can deal with that.
But not the prescriptive, not the prescription. Yeah, that's the problem.
But this other thing, to me, this is just and the fact that it might be more important in one place than another is not, the issue. But I think this is wild. Okay, practical issue. Oh, do you mind if I?
Oh, sure.
Anybody else? Okay, then I will keep going. Practical issue. One thing that has really struck me is that in taking part in these different discussions on open science, I remember this when we had this first meeting at the National Academies, that first meeting on the open science group. And I remember talking to Donna Getter about this, and I was saying, why are they making such a big deal about the reproducibility? I mean, honestly, in my training, and maybe this is as a social scientist, in my training, I'm not saying everyone was great about it, I'm saying that at least formally, we knew that reproducibility is an issue, and you have to be ready to give your data at any given time. I'm not saying that that's always smooth sailing, but it was sort of a standard.
I did the same thing,
Part
yeah.
of your scientific
Yeah.
method, and sort of your training, you know, that you would have to do it. But I was actually kind of surprised that different disciplines, like the sciences, you know, didn't necessarily have that kind of idea. At least that's what came up in this meeting,
Yeah.
it seemed to me, and we were talking, some of the social scientists there, we were talking about the science. Wow, that's weird, I thought we got that from the sciences.
I think it's important to separate two things.
I agree.
One of them is given a data set data set with the appropriate metadata and all the information attendant to it, all of that. Given a data set that should be, unless it's a matter of privacy or national security, which we didn't touch in national security part. But besides that you can go in and reanalyze it statistically, or because you have a different question on a data set, that's one type of reproducibility.
But that could be, yeah,
But
that's different.
there is the other one, which is, I'm a natural scientist, I did experiments, to expect that somebody will go ahead and reproduce the actual experimental data, will redo the experiments to attain that.
Yeah,
That
I
is
agree.
incredibly expensive, usually not practicable, and nobody, no agency will fund you
Well, that was
to
part of
do
what Feras
all
was
that.
saying.
Yeah.
So I think that those
That's a
things.
practical issue, but the principle, I guess, even
Right.
being out there was.
The
I was
principle is
surprised
out
it
there,
wasn't
but we need to think about what it means when you go to specific cases. And I mean,
Yeah, I agree. I mean, there are practical issues. That's why I said it wasn't
Right.
smooth
Right,
sailing.
right,
but
right,
the
right, right,
idea
right.
was there.
I thought I'll put it the other way.
I hear you.
Oh, sorry. I'll put it the other way. I've yet to hear anybody tell a PhD, prospective PhD student, hey, why don't you replicate that guy's experiment, I'll give you a PhD.
Although,
Yeah,
That doesn't happen.
And I will tell you in my own field, though, it doesn't happen often, but there have been cases where people have been called on the carpet because someone questioned some of their findings, and indeed, when you used the data and did what they did and everything, you weren't able to come up, and I'm talking with some big names, you were not able to come up with their results.
The only thing I've done is I've.
And it has happened, I'm not saying it happens often, and
Yeah.
you don't say that, you're not, and in fact, it would be other, these two cases that I'm thinking of in particular was other big names saying, wait a minute here.
I
And
question,
we
yeah.
did try to reproduce it, and then of course a lot of people were trying to. But the point is the principle was there. I didn't mean to actually get too much off on that, I was simply surprised that it wasn't.
But also there is.
That it seemed like a foreign concept to some people at the meeting, and that surprised me, I guess.
And also there is another perspective where, most of cases you described, right? Researchers are owner of those data because they collected those data,
Yeah.
they own those data.
Yeah.
But there are cases where, people do secondary data analysis or econ researchers try to understand certain business models, and then they get access to Google's data sets, Facebook's, unique data sets. They don't allow researchers to openly share. And then for those cases, it's not researchers' willingness to share or not. Sometimes it could be the business decision.
Yeah.
Happens all the time.
Well, of course, that's a different
Yeah.
issue.
Yeah,
too,
happens
right?
all the
But of
time.
course.
So,
Oh, please.
no, just a quick comment. So another layer of complexity in our field, I do artificial intelligence, and most of our experiments mean software code.
Yes.
We're writing programming code, right? So sharing the data is never sufficient because you need
Yeah.
the program that executes that data or the model that builds
Yes.
that data as well.
And also you need the exact infrastructure,
Right.
right?
Right.
Right.
The type of CPU
Yeah,
that
the preconditions, the
exactly
environment, the
the
environment of the
exact
experiment.
environment
Yeah.
to repeat
Yeah.
that so-called experiment with the
That's
exact
why-
data set.
Meteorology.
That's why
Yeah.
the
Meteorology
picture you
experiments,
showed
that's
was so important actually about that whole process.
This is why I loved IBM when I started out on IBM 370. We all had IBM 370.
Yeah.
I'm being facetious, but at one point, it sort of went back to the Tower of Babel. And I'm a linguist too, but we're talking back to this Tower of Babel. You know, your system
Yeah.
is compatible, and let's say, this is where we get in, you know, semantic impedance mismatch, use the old phrase. But also syntactic mismatches, where it's 90% there, but that 1%, that 10% kills you. You had a case in point of ICD-10. ICD-10 is incompatible with ICD-9. It should be compatible. It isn't. You know, and then in America, they don't know what to do with ICD.
Be dealt with in different ways, right?
I'm sorry?
That doesn't, never mind. I'm sorry.
There are issues of mismatches here. And cognates, and I wanted to talk about cognates too, where you think it means the same thing, your notion in AI and your notion in security is the same as my notion in whatever it is I do.
Right.
They're not, and we use the same symbol system, we use a Latin symbol system, we use, you know, we're not even talking about metrics. We're just talking about concepts. Take the notion of the concept of fungibility. It doesn't really apply in many of the epistemes in which we work, and what we really mean is repurposing of different skill sets. It's not a one-for-one exchange or exchange for different product exchange that, let's say, somebody would do in a financial market. Exactly, that's the problem. That's what I'm saying.
And we can just talk about big data in general is, and you would know this, is there's a lot of messiness out there. There's a lot of sloppiness out there, and if you're, you know, Feras mentioned a few kinds of cases where that can be really dangerous.
Right.
Actually, and repurposing of data that wasn't meant to be used in a particular way.
Oh, that happens all the
You don't
time.
want to have to reinvent the wheel all the time. It's hard.
Well, part of the problem is adequate metadata and training people to
Sure.
to characterize properly the data set state. But the problem with that is that A, is difficult, and B, who pays for that? And this is part of the
And the fact that
problem.
some people are better than others, are more careful than others, or approach their work. I mean, there's all sorts of things that can be thrown into the water here too.
Yeah, if you,
Well, the decision ended a long time ago, but
Another issue I wanted to bring up, this is just a practical issue, but this is for Wendy in particular, or anyone actually, if you have something to say about it. You know, the open access and publishing funds issue, I think, is actually a kind of an important one. And depending on your field, for example, some of the journals charge so much, it's exorbitant.
Right.
Talk about creating a digital divide or something. It's exorbitant, but, which means some people get left out of the loop too. But also, you know, I have to say in my own field right now, that, I'm a social scientist though, okay, but in my own field right now, some of these open access journals, not all of them, but I would say the majority of them are almost looked at as sort of just next door to being a vanity press.
yes,
Right.
yes, that's the other thing, yeah.
Yeah.
And a large part because of this, but, and also because you were saying that in providing these funds, they would provide them for non-predatory journals. So
Right.
how are they actually delineating what's predatory and non-predatory?
Right.
Because, I mean, we think we have a sense of it, but there's.
No.
It's easy to be duped, yeah, so I think, well, there used to be, you may have heard of it, there was something that was called Beale's List.
Yes.
Right, and then that was removed, that he had to take that down. And there's now some product that's being sold by some press that's an index
Oh,
to
next group we got.
open access.